We have one part left to 5.5, and it is the shortest part of the lesson. And it's dealing with what's called conjugate roots or imaginary roots. So a conjugate root is going to involve a radical sign or a square root sign. And the idea is if you have a function that has a root that has a square root, it always has a partner. Meaning if you have 3 plus the square root of 2, we would call that a irrational or a root 0. It will always have the exact same solution with the opposite sign in between. So that will mean that 3 minus the square root of 2 also is a solution. The idea is square roots always come in pairs, which we've seen as we've been solving things with square roots since the beginning of chapter 4. So again, if you have a positive irrational, you're going to also have the negative. And it doesn't have to be as complicated as that. It can be something as simple as the square root of 3. If the square root of 3 is a solution, then so is the negative square root of 3. So you always have that opposite. They always come in pairs. The same can be said for imaginary roots. So imaginary roots are the ones that have i's in them. So the idea is you will always get those in pairs. You'll never have one imaginary answer. It will always be an even number. You'll have 2 imaginary answers or 4 or none. And the reason is because they come in pairs, one with a positive sign and one with a negative sign. So if 7 minus 4i is an imaginary 0 or imaginary root, then that means 7 plus 4i is also. If it's something as simple as just 8i, then it would also have negative 8i. So again, they come in pairs. Square root solutions, square root zeros come in pairs, imaginary ones come in pairs. So you'll be asked really quick questions. So this is the only other screen we want to talk about, is looking at if I have certain solutions or certain roots, what are the other ones that automatically have to be there? So the first one says a quartic polynomial. So quartic means 4, degree 4, should have 4 solutions. And we know that one is 1 plus the root 2 and one is 5 minus 3i, and it wants the other ones. So if 1 plus root 2 is a solution, then 1 minus root 2 is a solution. If 5 minus 3i is a solution, then 5 plus 3i is a solution. So we have the conjugate or the pairs of the solutions. Next one says a cubic polynomial, cubic meaning 3 solutions, has roots 3 plus 2i and 5 halves, wants to know the additional one. Notice it only mentions that there's one additional one because there's only one that is, in this case, imaginary. Its partner solution is 3 minus 2i. This one doesn't have an additional solution because it doesn't have a square root sign in it and it doesn't have an I. Those are the only ones that have to come in pairs. And the last one says a polynomial, so we don't know what the degree is, has all these roots, at least 4 of them, wants to know how many more it has to have and what they are. So if you look at the first 2 solutions, negative 2, that is not irrational, that is not imaginary. It doesn't have to have a partner. Same with 5. 3i, though, is imaginary. So if 3i has a solution, then negative 3i has to be. If root 5 is the irrational solution, it has to have negative root 5. So this must have 2 additional solutions, and there they are. So that is the last piece of 5.5. If I give you a solution that is either irrational or imaginary, you should be able to come up with its conjugate or its partner solution.